All right, we're back. Today's discussion is about the properties of logarithms, and this is section 10-3. Now, if you have already covered 10.1 and 10.2, hopefully you spent a little time with those. There's a lot of information in just two sections, so if you're having difficulty with those, please go back and tackle those. All right, the properties of logarithms. We need to talk about properties of exponents as we do this. If you recall, in the exponent world, when we requested to multiply two polynomials or two monomials together with the same base, we find ourselves adding the exponents. That's 3 plus 4, or a to the 7 in this case. So what's happening is that the request was to multiply, and what we find out we are going to do is add the exponents. Now remember, we said this was odd that we were asked to do one thing and we find ourselves doing something different. Well, the same thing kind of applies in the logarithm world. If the request is multiply, what we do is we add the exponents. Now the same thing applies in the logarithm world. Here's what it looks like. If I had let's say the log base 8 of a times t, that would be equal to the log base 8 of a plus the log base 8 of t. Well, this looks a little weird, but we've taken, and if the request was to multiply, notice a times t here, we find ourselves adding the logs together. Now remember, logs are exponents. You're adding exponents here. The log base 8 of this result, at, is equal to the log base 8 of a plus the log base 8 of t. The request is multiply, we find ourselves adding. Let's look at another example here. Log base 10 of 5x y. Well, that would be log base 10 of 5 plus log base 10 of x plus log base 10 of t, or excuse me, y. All of these are being multiplied together, so we find ourselves adding the exponents. These are exponents. So the request again is to multiply. Our request is to multiply, and we find ourselves, what we do is we add the exponents. This seems a little bit odd, but we just need to get used to the pattern that you see here. Now the next property of logarithms, we'll continue to come back and review that, is that property of division. Well, in the exponent world, if we had something like a to the 5 divided by a to the 2, we say, oh, if our request is to divide, what we do is we find ourselves subtracting the exponents. Well, what did we get? Well, 5 minus 2, a to the 5 minus 2, or a to the 3. Once again, the thing that we do is different than what the request is. That seems odd, but if the request is to divide, we will subtract the exponents. Now, how's that look in the log world? Okay, well, let's go over here. Log base 8 of t over x. Now this is division, right? So if this is division, the request is to divide, we're going to go log base 8 of t minus the log base 8 of x. Notice this thing in the denominator has a negative sign in front of it. Let's do another one. Log base 10 of 5 over 15 is equal to the log base 10 of 5 minus the log base 10 of 15. Again, if the request is to divide, we find ourselves subtracting. I hope you're beginning to see kind of a pattern here, that when we multiply, we add the exponents. When we divide, we subtract the exponents. Let's try a combination of the two. All right, let's take a look at this one. Notice we've got multiplication in here, and we got division. Now remember, each of these items on the bottom are actually being dividing into. So this is going to be a combination of four things. Let's see what it would be. Log base 5 of A plus the log base 5 of B. Notice they were multiplied, so we are adding them together, minus the log base 5 of X minus the log base 5 of Y. Now some of you say, well, why is that one minus? Because it's multiplied. Actually, this Y is also in the dividend, or in the denominator. Anything in the denominator will have negative signs in front of it, and anything in the numerator that's being added will have positive signs. There's a positive sign here you don't see. Plus numerator, denominator, denominator. You can see that these rules will apply in some combinations. Let's try another one. Log base 7 of well, let's just use some numbers this time. 3 times 5 over 6 times 2. Well, what would this be? Let's see if you can get ahead of me on this. Log base 7 of 3. There's a plus sign in front you don't see. Plus log base 7 of 5 minus log base 7 of 6 minus log base 7 of 2. Again, anything in the denominator is going to have a minus sign in front of it. All right, let's take a look at the third property. Once again, the request is, if the request is to divide, we find ourselves subtracting the exponents. Okay? All right, the third and final property in today is this one, and it's even more important in many ways than the other two, because we use it a lot more. We have a lot more reason to use it. Let's review what this was. This is in exponents. It said if we raise something to a power, we raise a power to a power, we end up multiplying the exponents. Okay, we're raising a power 4 to another thing, to another power, we multiply the exponents. So this is a to the 3 times 4, or a to the 12. The request here was to raise to a power. Raise to a power. And what we find ourselves doing, what we do is we multiply the exponents. We multiply the exponents. If we're asked to raise to a power, we multiply the exponents. Let's see what that looks like. All right, let's take a look at this problem. You'll notice that this time the result here contains an exponent. And so what the request is here, just like up here, the request was to raise this to a power. Well, what does that mean? Well, if a request is to raise to a power, we are going to find ourselves multiplying. I'm going to take that 2, and I'm going to use it as a multiplier now. Now, I could put it in either side, but I'm going to put it up in the front, and I'm going to put a dot here for now. Excuse me. I'm going to put a dot here, but eventually you won't need the dot there. 2 log base 5 of x. Notice what's happened here. The request was to raise to a power, and we find ourselves multiplying that exponent. That was an exponent. It's getting multiplied times an exponent, which is a log. Logs are exponents. We're multiplying an exponent times an exponent. We're multiplying. So when we raise to a power, when we're asked to raise to a power, we find ourselves multiplying the exponents. Let's do another one. Log base 10 of, let's go 3 to the 5th. Okay, well, what would that be? Well, that's log base 10 of 3 raised to the 5th means now I'm asking to power. I'm going to multiply, and I'm going to basically drag that 5 around to the front and multiply it. I don't need to put the dot there, but there it is. Now, this property is easy to use. It's very important. We're going to find that what this is going to do is solve an enormous amount of problems for us. Now, let's take a look at just a combination of all 3 properties. All right, let's take a look at this one, and we're going to apply all 3 properties here. I don't need that dot in the middle, but I just stuck it there for now. Now, I've got a product on the top, I've got a division problem here, and I've got powers as well. First thing I'm going to do, I'm going to kind of do this in 2 stages, although in the future you can probably do it all at once. We'll do some all at once. But this is log base 5 of x squared plus, remember the request is multiply, so I'm adding log base 5 of y to the 3rd, and then dividing minus log base 5 of z to the 4th. So note again that the bases haven't changed, and that the divided one has a subtraction sign in front of it, and the ones that are multiplied on the numerator both have positive signs. Now this is just half done because now I can take each of these exponents and roll them around to the front under the powers of powers act, okay? So the request is to power, so we're going to find ourselves bringing it out to the front and multiplying. I'm not going to put a multiply sign there. Drag that 3 around to the front. Drag that 4 around to the front. Now it's negative 4 really, times log base 5 of z. Now take a good look at this. We've applied all 3 of the powers here. The request to multiply, we added the exponents. The request to divide, we subtracted the exponents. And the request to power, we put them around to the front to multiply them. You don't see the dots here, but I could put them in there if I wanted to. That particular property this particular problem involves all 3 of the properties. Now let's do some more problems with it. All right, we're going to do something that seems a little odd here, but the book is asking us to kind of use a little creativity here, use our creative brains to see if we can solve this problem. And you're going to end up using possibly your calculator on this, but you probably don't need it. You could do it by hand. But to use your brains to try to figure out what log base 2 of 48 is, if log base 3 is of log base 2 of 3 is approximately this. Log base 2 of 3 is approximately this. Well, what we want to be able to do, this is just an exercise. This is not the kind of thing that you're going to be doing mostly when you're solving logs in the real world. This is just a little practice to see if we know how to do this properly. I'm looking at the number 48, and I'm trying to find a way to break this apart into factors and powers that use the numbers 2 and 3. Well, now I'm trying to be creative here, and I realize, I could call this 48. I could call it 16 times 3, but 16 happens to be 2 to the 4th power times 3. Now notice I'm trying to use the numbers 2 and 3. I may end up using other numbers for exponents. And now I have it written this way, and I can go ahead and use the properties of logs to solve this. Well, what is this, using the properties of logs? Here we go. Log base 2 of 2 to the 4th. Well, that 4 doesn't have to go up here. I can put it out in the front. Plus, remember the multiplication here, log base 2 of 3. Well, now, how did I get log base 2 of 2 with a 4 out in the front? Well, 2 to the 4th. I brought that 4, the 4 was here, and I brought it around and put it up in the front. Now, with this, I know a lot here that, first of all, I know that log base 2 of 3 is that thing up there. So I have a decimal, 1.5850 approximately. And I know that the log base 2 of 2, well, if you recall, the log base 2 of 2 is actually equal to 1. Well, why is that again? We're reviewing this. If I bring the result down and throw the base to the other side, what would the exponent have to be on 2 to give me 2? Well, it would have to be 1. So this has to be a 1. So anytime you see something like this, it's a 1. Okay? You're going to see this a lot, so get used to it. Okay? And of course, up in the front, we have 4 times 1. Well, 4 times 1 then is 4 plus 1.5850, and I can do this without a calculator. It's 5.5850. Now, why did we do this? So this is some practice on breaking stuff down. You'll need to be a little creative. You have to be able to be a little bit creative to get from here to here, and you'll get good at it. Okay? Let's try. All right, let's try this problem. This time, the book gives us 2 proximate logs. Log base 3 of 5 is this, and log base 3 of 20 is this. And they ask us to find the answer to log base 3 of 4. Well, what is that? Well, I'm going to try to be creative, and I'm going to use the numbers that they gave me up here, 3, 5, 3, and 20. I'm trying to use those numbers to see if I can figure out how to get 4. Well, I see that 4 can be written as 20 over 5. I'm trying to use the numbers they gave me. 4 is the same as 20 over 5. Well, there you go. This is the same as 4. So now using the properties of logs, and this is division, I'm going to go log base 3 of 20 minus log base 3 of 5. Now, why am I subtracting? Because it's division. Anything in the denominator will have a minus sign in front of it. So if this is the right setup, now I'm just going to substitute the numbers in here. Log base 20 is 2.7268, and log base 3 of 5 is 1.4650. You can subtract it manually if you wanted to, but if you want to use your calculator, you can do that also. We end up with 1.2618. There's our answer. Now again, the book is just doing this to see if you can practice working with these, and they're asking you to be a little creative. Use the numbers that they give you at the top of the problem somewhere to see if you can come up with a creative way to rewrite. All right, let's tackle this one. They're going to start us off and say, okay, if the log base 4 of 6 is this amount here, whatever that is, let's find the log base 4 of 36. Let's see if we can use 4 or 6 as some basis to figure out how we can come up with 36. Well, I know that 36 happens to be 6 squared. I'll put this in parentheses. I don't necessarily need it in parentheses, but I'll put it in there. 36 is 6 squared. In fact, let's take the parentheses out of there. We don't need them. Okay. Well, using the powers of the property of powers, I can drag that 2 around to the front. Why is that? Because if the request is to power, I find myself multiplying the exponent. So I'm going to drag that around to the front and multiply. And now I know what log base 4 of 6 is. It's right up here. So 2 times that number. And you can use your calculator here if you need to. Turns out the answer is 2.585. 5850 or 585. So once again, they're just giving us problems like this and asking us to find creative ways to write that. You'll notice I used the number 2 here. Sometimes exponents may appear that aren't in your list of numbers, but trying to find creative ways to write something. So sort of a little bit like smell a base here. Oh, I smell that I can write that 6 to the 2 power. All right, let's take a look at the next topic. All right, we are now ready to start solving logarithms here with these properties. And if you recall from previous lesson here, we can solve logarithms if we have a single log on both sides. That's one way to do it. So can I turn this log into, these 2 logs into a single log? We could call it maybe a monologue or something. I want to turn these two logs into a single log. Well, sure I can, because that 3 can roll around back, can take a trip back up here and become an exponent. And this minus sign means that this is a denominator. So let's rewrite it. Log base 5 of x, because this was positive out here. X is on the top. And that 3 rolls around on top of the x. And then this is on the bottom because it's a denominator, so we're going to put 4 down here. Again, both the logs are log base 5, so I can do this. Once again, x is going to go on the top because it's positive, and that 3 is going to roll around here and become an exponent. Then this is, because of the subtraction sign, this is in the denominator. So now we have a single log on both sides. Well, if there's a single log on both sides, as we learned in a previous lesson, same base, we can just set these equal to one another, and we will. Now, let's cross multiply. I'm going to multiply both sides by 4 here, or you can say cross multiply, and I get x cubed equals 64. Or if I take the cube root now of both sides, I know that x has got to be 4. X is 4. Now, just as we mentioned before in previous problems, we have to always check our answers, because there is a restriction, mentioned this last time, there's a restriction on the result. Anything that's in the result area, like this x is right here in the result. And the restriction is that the result must be greater than 0, and it is here. If x is 4 and I put 4 in there, oh, well, 4 is the result. That means it is greater than 0. So we've solved this problem. X is equal to 4. Let's do another one. All right, I want to underscore again that you've got to check your answers in these logarithmic solutions, because the result, not x, but the result itself cannot be negative or 0. All right, now we also learned another technique for solving logs, and that is if you have a single log on one side. Well, is there a way that I can turn this into a single log? Well, sure there is. They have the same log base, and since this is plus sign, I'm adding these two together. That means the results get multiplied. So I can turn it into a single log. I got to use an extra set of parentheses here, because I want to make sure the whole thing gets raised to that log. So if I find myself adding exponents, remember logs are exponents, then what the request was to multiply these results, and that's what we've done here. Now, at this point, we're going to solve this the way we did from the very beginning, by dragging the result down, throwing the base to the other side, that's 4's over here, and raising it to the exponent. The base came over here, exponent came down. Now this is simply going to turn out to be a quadratic solution. Let's distribute this. We get x squared minus 6x equals 16, and if we subtract 16 from both sides, we get this equal to 0, so we can solve the quadratic. Remember, you got to set it equal to 0 to solve the quadratic. Now, we've got that product sum game. What two numbers will give me negative 16? Negative 16 when I multiply, and negative 6 when I add. Well, let's see here. If I multiply together 2 and negative 8, 2 times negative 8 gives me negative 16, and 2 plus negative 8 gives me negative 6. That works. So this factors to x plus 2 and x minus 8. Now you notice I didn't have to factor here using factoring by grouping, because I had a 1 up front. So I could just jump straight to the end. I could just jump right in here. So these are my two factors, and of course using the zero product property, set each one of these equal to 0. We'll do that here. We probably can do it in our head, but let's do it real quick here. Set each factor equal to 0 using the zero product property, right? And so x has got to be a negative 2, or x has to be 8. But now wait a minute, we better check these back in the original problem. Well, let's put this negative up here and see what happens. Well, if I put negative in here for x, that's not going to be allowed because the result must be greater than 0. And that result would be -2. That would not work. So this is extraneous. It doesn't work over here either. Let's check 8. If 8's in there, that's okay. And if I put 8 in here, I get 8 minus 6 or 2, and that's okay. So this is the one answer that's okay. The other one is an extraneous solution. Now, we're going to one more problem, and I'll cut you loose. All right, let's try this one last problem here. I've deliberately written this kind of backwards, so the bigger thing or the longer string is on the right, just to make sure you see so you're going to see things in different ways. Now, if I want to solve this equation, I need to get this sum of logs and turn it into a single log. Well, can I do that? Well, sure I can. This 1/4, even though it's multiplied here, is going to roll around to the top up here and become an exponent. And this 1/2 is going to go roll around to the top up here and become an exponent. Let's see what we've got here. Log base 2 of 16 to the 4th power plus log base 2 of 49 to the 1/2 power. Now we could continue to write the next step here, but I realize that the 4th power of 16 is 2, the 4th root of 16. So I'm going to rewrite this as just 2. 16 to the 4th power is 2. Okay. Also, I recognize that 49 to the 1/2 power, well, that's the square root. That's log base 2 of the square root of 49 is 7. Okay. Now, this is the sum of logs, and so if we find ourselves adding logs, the request must have been to multiply. Again, that's an odd thing, but base 2 of 2 times 7. 2 here and 7 here, or 14. Log base 2 of 14. All right, now if you recall, if the log bases are the same on both sides, that's a big N there. If the log bases are the same on both sides, the results can be set equal to each other. So the answer here is simply 14. This turned out to be problem number 25 in your book, and you're going to do that today. I already did it for you here. So give this a shot. Try these properties. If you get confused, go ahead and watch the video again, and I'll give you another assignment tomorrow here, which goes a little bit into some of these word problems. Have a good one.